locate any airflow problems we have in an air conditioning system. If we get an indication of low or high airflow as a result of measuring the cubic feet per minute CFM for the system, then this is a very handy tool to locate where we need further investigation to expose what the problem is. You just simply remove the cover. You can place it on the back or set it aside. Turn the unit on with this button. The unit will zero a null when it's turned on, so you don't want any of the tubes attached to the pressure ports here on the top. You also want to place this unit on a surface. It's got a magnet on the back that you can attach it to a metal air conditioning unit, or you can lay it horizontally on a return plenum or the top of the unit, that kind of thing. But you want to put it in a fixed position as you do your measurements after it's zeroed out. So it's zeroed out. The unit of measure we're using is inches H2O. You can change it to PA and multiple other units of measure, but we typically use H2O, inches of H2O. So when we take the measurement, we're going to place the pressure probe into the unit in the suction side of the fan and in the discharge airstream, either before or after the component that we want to measure. This is not a pitot tube. There's no hole in the end. There are holes in the side. So this installs in the airstream with the point here facing into the direction of the airflow. Attached to that is a vinyl tube, and that vinyl tube, when we take our measurement, is going to attach either to the positive barb or the negative barb. So we can take a single pressure, or we can use two of these probes and attach it and take a total pressure, total negative and positive. It will add them together and give us a total pressure. If we want to measure total external static pressure for this furnace as an example, we would place one of the probes into the airstream on the suction side of the fan section. We could also place it in the return duct facing the airstream, of course. This airstream's coming up going this way, so we would place this probe in the side of this unit here, and that would give us our negative pressure. To check the other side of the unit, if we're just checking this furnace, then we would want to insert the second probe, the positive side, on the discharge after the heat exchanger in the furnace, but before the coil, and that will give us total external static pressure that will tie into the fan curves or airflow charts for this furnace. If we wanted to check the pressure drop across a coil and compare it to published data for this coil, then of course we would put one probe in below the coil and one probe in on the discharge side of the coil. You want to get these probes in areas where there's as little turbulence as possible to get a good reading. You might have to try 2 or 3 locations to get a good idea of where that might be. Again, you can do some exploratory probe searches to determine what those areas are. But a good information is, of course, pressure drop across the filter. So you could take your reading in the return air and then in the suction side, and that would tell you how much pressure drop you have for this filter. If you have a highly restrictive filter, that could be a problem. You could take your pressure drop across the coil and compare that to published data, and that would tell you whether you have fouled or stopped up coil. If you have a high static discharge pressure, that would tell you that you have a restrictive duct system. If you have a high suction negative pressure from the fan inlet, then that would tell you you have a restrictive filter, restrictive return system, restricted return air grill, that kind of thing. So these units typically for residential are rated at a 1/2 inch of static pressure, which gives you a quarter, 0.25 on the suction side and 0.25 on the discharge side. It's not unusual to find these units installed with restrictive return and restrictive supply and up to 1 inch of total external static pressure.